In this problem, we're to find V0 using linearity and the assumption that V0 equals 1 volt. So if you remember, when our circuits are linear, that this voltage V0 is a constant times the value of this voltage. So the approach here is start off and assume a value of V0 and work back to our input voltage, and then we can use what we find there to scale the result. So here's our circuit. Now what we've done is we've assumed that V0 is 1. We're going to work our way back to the input to find what Vs is. So let's start over here. We know this is 1 volt across 4K. So that tells us that this current is 1/4 of a milliamp. Then that's the same current here, so that tells us that this voltage is 0.5 volts with that polarity, okay, from Ohm's law. Now if we do KVL around this loop, that's going to tell us that the voltage across this resistor is 1.5 volts. Now we can find this current, and I'm going to call that current I3. So I3 then is 1.5 divided by 6K, which is 1/4 of a milliamp. Now, if I define this current as I4, then I can apply Kirchhoff's current law here. So I4 is 1/4 of a milliamp coming from this branch, and another 1/4 of a milliamp. So it's 1/2 of a milliamp. Now that tells me that the voltage across this resistor is 1.5 volts with that polarity. Now if we apply KVL around this loop, that tells us that the voltage across this resistor is 3 volts with that polarity. And if we define this current as I5, then I5 is 3 divided by 12K, or 1/4 of a milliamp. Now we can apply Kirchhoff's current law here to find the current I6. So I6, then we have 1/4 of a milliamp leaving through here, another 1/4 leaving through here, then another 1/4. So it's 3/4 of a milliamp. Now we know I6, that tells us the voltage across this resistor is 3 volts with that polarity. Now we can apply Kirchhoff's voltage law around this loop, and if we do, this will tell us that this voltage is 6 volts. Now we can calculate current I'll call I7 through the 8K resistor. So I7 is 6 divided by 8K, 3/4 of a milliamp. Now if we apply Kirchhoff's current law, we can solve for this current I8. So I8 is 3/4 of a milliamp here, and another 3/4, and that's 1.5 milliamps. Now the voltage across this resistor by Ohm's law is 6 volts. So now if we apply Kirchhoff's voltage law around this loop, we'll get Vs is 6 plus 6, or 12 volts. Now, when V0 is 1 volt, we know that Vs is equal to 12. So now when V0 equals 1 volt, Vs equals 12. So now when Vs equals 20, then what that tells us is that V0 is 20 over 12 times 1, or 5/3 of a volt. So when the input voltage is 20, that tells us that the output voltage is 5/3.